all of a sudden you're connected to an angling community. You could learn the history of this fish that you've caught. We've always wondered about that, and now we can actually answer it.
Welcome to the Wild South Podcast. I'm Dave DiBenedetto, Editor-in-Chief of Garden & Gun Magazine.
And I'm Eddie Nickens, Contributing Editor for Garden & Gun.
Together, we're talking with the most interesting outdoorsmen and outdoorswomen in the South and beyond.
Quail hunters and duck hunters, trout anglers and redfish fanatics, musicians, scientists, writers, wild game cooks, and frankly, a few wildcats we dig up along the way.
We're talking to legends and legends in the making.
All with unforgettable stories of life way beyond the sidewalk.
So Eddie, the heat of summer has arrived in Charleston, South Carolina. And when it does, my mind turns to brook trout. I can't think of anywhere else I'd rather be than up in the mountains with my 3-weight fly rod, bushwhacking off a mountain trail to a tiny stream to catch brook trout.
I mean, who could not be in love with this fish? It's the only native trout that we have in the South. They're not giant. They're actually quite small often, but they live in the wildest, most tucked away corners we have left. In the clearest, cleanest water left on this planet. And they're hanging on, not quite by a thread yet, but the guy we're going to talk to today, Dr. Nathaniel Hitt, is making sure that the future for brook trout looks healthy. Than, as it likes to be called. He's a research fish biologist at the Eastern Ecological Science Center up in Kernersville, West Virginia. This is a big USGS study facility. And inside of this place, he's built, as he tells us, a trout stream, like a laboratory-sized trout stream where he can model.
It's like the world's coolest aquarium, I believe.
Yeah, right. Like whatever they have at Bass Pro Shops, but like coming out of a scientist. He can forecast stream flow and manipulate temperature and kind of study the effects of climate change, the effects of environmental change and water chemistry. I mean, it's super cool. His focus is on brook trout and what we can do to make sure that these things are around for generations and generations.
He's also using AI as a conservation tool. I mean, that part of this conversation really blew my mind, Eddie.
Yeah, you've often accused my intelligence of being artificial, but in this regard, he's going to be relying on anglers. I mean, that's the whole AI thing, citizen science. Right. Anglers are going to be able to sign up and log on and help make a difference. It's super exciting.
Yeah, no doubt about it. Let's hear from Than.
Nathaniel Hitt, brook trout maestro, scientist, Southern boy. Man, welcome to the Wild South Podcast.
Thank you, sir. It's so good to be with you.
And Nathaniel, you like to go by Than, correct?
Yeah, that's right. Than is my nickname. It was an old backpack nickname. It stuck around for 30 years, so we'll keep it.
All right. Well, Than, I am delighted to have you on the show, as is Eddie, I know. We are huge fans of brook trout, both of us. Certainly, it's my favorite freshwater fish. Eddie, can you make that declaration?
I will make that declaration.
Wow.
It is my favorite freshwater fish. And I've been really, really fortunate to chase them for quite a while.
Well, I love it, you guys. I'm in good company here because I'm biased too, and I'm on board 100%.
Well, good. We'll jump right in. Dave and I have talked a number of times about how much we do love brook trout. I think you live in the geographic center, Than, of brook trout range. I mean, when you take the whole range from, I guess, Georgia up through Labrador, maybe you're smack in the middle of it. Why don't you tell us where you are and what you do?
Well, I'm in West Virginia. The U.S. Geological Survey has a research station out here, the Eastern Ecological Research Center, and Southern Appalachian Mountains is where I am and where I work. Love it. Now, brook trout down here, of course, are very different from what you're going to find up north in the lakes. there's all sorts of diversity, which is fantastic. In the Southern Alps, of course, we're talking about mountain streams, highlands, some of the best places on earth, in my humble opinion. But as we move north, you see lake populations. You also see some really cool salter populations. There are migratory fish that move to the ocean into brackish areas and move back. They're moving to feed. They get pretty big, a lot bigger than the Southern Appalachian variety that we know so well.
I had no idea that there is an anadromous, right? That they were.
That's right.
Could be anadromous. How big? Like 4 or 5 pounds big, or?
Yeah, you're talking. Well, I mean, once again, you're talking about a 12-inch fish being kind of a lunker,
right?
But you do see that growth where fish are moving to access forage. They are getting, much larger.
Wow.
Now, you go over to the Great Lakes. You can't forget about the driftless. There are native brook trout up in the driftless section too. And some of those are migratory into the Great Lakes. We call them coasters. So, it's really about the landscape. And these fish reflect the mountains down here. They reflect the connection to the ocean. They reflect the lakes of the north. If you go to the northeast, it's just fantastic.
Yeah, I mean, that's one thing, Than, we were... Eddie and I were discussing is why. What is it? What do you think it is about the brook trout? I mean, obviously there's this great history. Tell us what you think makes them so cherished.
Yes. Well, let's zoom out a little bit. I mean, these fish are basically the living jewels of the mountains. Now, about 30,000 years ago, there was a big old glacier parked in Ohio, Pennsylvania, that was called the Wisconsin Glacier. It didn't scrub down the Southern Appalachians, but it sure did refrigerate them. And so any fish that was going to be surviving and thriving in the mountains here had to deal and to really embrace cold water. So that's why these guys are such an important indicator of climate change. As things warm up, they basically have seen the Appalachian Mountains transform and they've survived through it all. Question is, will they survive in the future?
Right. Which leads us into a little bit about what you're doing, right? I mean, that's the question you're trying to answer, right?
That's right. But, it starts with something more basic, I think. It's just, let's face it. I mean, these fish are gorgeous.
Right.
Look at these spotting patterns. You all know what I'm talking about.
Oh, yeah.
I mean, it's nature's jewels. I mean, it's like nature's firework display. What analogy do you want to use? You got, yellow spots, red spots, blue halos. The back has all these wavy yellow track marks on it. It's amazing. And this is the only native trout in Appalachia, of course, right?
Yeah.
And it's one of the only ones to spawn in the fall, which their coloration goes berserk. You'll start to see intense reds, the black bellies of males. The spots get really highlighted. And a theory about why you see that amazing coloration show up in the fall. Well, if you're walking a stream in that time of the year, what do you see? You see
leaves,
red maple leaves,
fallen leaves. Yeah.
So one of the theories about why we see such amazing colors on these fish in the fall when they're spawning is because it matches the leaves that fall into the stream, those reds, those yellows. So it's really possible that they're using this as camouflage from predators. I mean, the herons, the water snakes, there's a lot of hungry animals out there. So that's one of the reasons we think that those colorations show up. It's also communication to other fish saying, hey, it's spawn time. Let's go.
Do the female and male have the same amount of coloration during spawning time?
They both get colored up. The males are a little bit more vibrant, especially on their bellies. You'll see those black stripes, and they really do show up.
And then what about the back, the top of the fish? Does that help camouflage them from above?
Absolutely. You think about it from a predator's perspective. It's all they're seeing is the top, those track marks. We call them vermiculations. It's like worm tracks.
Right.
That's just great camo.
Hey, we talked about this glaciation aspect, Dan. I'd love to hear you drill down a little bit more on the regionality of the fish that we have in the Southern Appalachians. How these fish are different from fish further to the north. They're different from the Maine fish. They're different from Labrador fish. But even within the Southern Appalachians, from watershed to watershed, there are these genetic differences. I think that's one of the reasons that makes these fish so special, is that they have evolved in some instances to be exactly who they are, but only exactly where they live in a particular stream or river. Talk to us about that.
That's right, Eddie. So you think about it in terms of where you're connected to with cold water. So every little watershed kind of has its own population of fish that can have local adaptations, sort of genetic diversity at that scale. That's amazing.
That's amazing.
So, but another important part of this is that we've learned from some recent genetics work that when we stock hatchery strain brook trout into these wild populations or near these wild populations, they're not randomly mating. They actually don't interbreed into that wild population as much. And I suspect that's because the hatchery strain fish, have been selected for fast growth, survival in a hatchery, etc. And this is super valuable for anglers. Don't get me wrong, it's super valuable. But the good news is that those wild fish populations aren't getting degraded in general by hatchery stock. So that's some good news.
Yeah, I would have never guessed that.
How do they interact then with the other two trout in the Southern Appalachians?
Right.
So the rainbow and the brown, of course, are non-native. Talk to us about how that community sort of lives together or doesn't.
So, of course, rainbows are the most stocked fish in the world. Rainbow trout are native to the west coast of the U.S., goes all the way up through Kamchatka, which is the Russian Far East, and that's the native range of rainbows. And then, of course, brown trout are native to Europe. Brown trout, rainbow trout, and brook trout all have somewhat different habitat requirements, but those are fine differences because they all need cold water, they all need clean gravels to spawn, and they all need that complicated woody debris, the kind of streams with structure, right? That's where you're going to find fish. Anglers know this 100%. So those are some of the commonalities, but there are some differences. Rainbow trout generally have a higher thermal tolerance. Brown trout maybe a little bit higher than brook trout, but a little less than rainbow. And the most restrictive, or the one that requires the coldest and cleanest water, that's our native brook trout.
And tell me, do the rainbows and browns eat brook trout?
Well, everybody eats everybody. That's the story of ecology, right?
Right.
One of the things that we've learned in some experimental work we've done, I run an experimental stream lab at the USGS here in West Virginia. And one of the things we were observing is that brook trout and brown trout, how they interact is a function of temperature. So basically, the highest temperatures are right at that edge. We're talking about, 68 Fahrenheit, which is 20 degrees Celsius. Right about there is where we see this important tipping point where brown trout really outcompete brook trout. At the colder water, they hold their own, so anything below that, they kind of hold their own better. And the interesting kicker is that when you take brown trout out of the mix, brook trout are better able to deal with warmer water. Now, that's important because, look, we may not be able to change water temperature, but we may be able to change, stocking practices, and that could really benefit these native fish in some cases.
All right. I'll admit that I love a good aquarium, and I pretend like that my children really want them, but it's really me, and I'm the aquarist in our house. You said experimental stream lab.
That's right.
Tell me what that is. Is that a stream in a building, like with rocks and water flow and...
That's right. Yeah. So imagine a bunch of tanks hooked together, round tanks with rectangular flume tanks hooked to another round tank, to a flume and on. And we'll recirculate water through that so we can control temperature, we can apply some filtration, et cetera. But the real beauty of this is that you can manipulate temperature precisely. And that's a huge piece of the puzzle. And the importance of having these round tanks hooked to flume tanks is simulating some structure so that these fish can establish territories, and that gives them kind of a semi-natural environment so that their behavior is meaningful. So we can take what we learn there and put it out into the real world, because that's what we care about, right? So we take these complicated natural systems, kind of simplify them for an experimental stream lab, learn some stuff, and then turn it back out into the real world and hopefully do some good for conservation.
Hey, what else can you manipulate in this system, Dan? You can manipulate temperature. Can you manipulate velocity or turbidity or...
Velocity is fixed. Turbidity is something we can manipulate. And actually, there's an interesting story. We anecdotally saw a huge effect of turbidity when we had some wild brook trout in the stream lab a couple years ago. There was a storm event, and a little pulse of sediment came through, and these fish went berserk, spawning. They were kicking up reds, which are depressions in the gravel where they lay eggs. Mm-hmm. We saw successful spawning, and it was triggered by the pulse of sediment coming through, which is natural. And our thinking about this is that that has to be either a smelling cue, like the olfactory stuff, or a visual cue. But it's interesting because velocity was not changed. To your question, we don't manipulate velocity. It's the same amount of water. So the tactile stuff, the feeling of hydraulics, we always assume for years that that's what triggered fish to move upstream to spawn. The pulse of rain comes through, they feel it, they move upstream, but that doesn't explain it. So that's one of the beauties of an experiment. You learn things, and that was just by happenstance, but I think that's important because that tells us something about how these fish have survived for so long. It's either they're smelling the difference in water chemistry with sediment, or they're seeing something different, and that tells them it's go time.
From an angling perspective, a lot of places in the country, there's a real big emphasis on being super careful wading and that sort of thing, Dan, during the springtime, mostly out west when the trout are spawning. How much of an issue is that in the South in terms of fishing and wading in the streams in the fall when the brookies are on the reds? And what do we look out for?
Yeah, that's a good question. Now, we don't want to put extra stress on spawning fish. So it's October, November when we want to cool off the angling. And also we want to avoid disturbing a lot of the pea gravel, the spawning beds. It's something that hasn't been fully studied, but is the best practice. It's just wise to avoid putting more pressure on them in the fall when they're spawning.
And Than, let's make it clear. You are a fisherman yourself, a fly fisherman, right? You love catching brook trout.
I love it. I love the adventure. And one of the things I love the most about it is because I promise you, if you're fishing for brook trout in the Southern Appalachians, you are in an amazing place.
And do you have, while we're talking about catching them, do you have a favorite fly? I mean, you must know a lot about what these fish eat, more so than any of us, right?
Oh, yeah. It's pretty funny, though. I wish I was a better angler. We're always improving, right? I have to admit, most of my angling is, if you can call it that, is with my backpack electrofishing system where we're doing, quantitative surveys. But mayfly patterns in the spring. And also, I get into the terrestrials, too. When things cool off, get out there in late summer. But keep it super light, ultra light. We're going size 16. And actually, for places like Shenandoah National Park, where we've done a lot of work and have done a decent amount of fishing up there, you have to be essentially like a ninja, right? You are climbing boulders. Some of these pools are gorgeous, but it's all about the presentation and that fine touch. So that's just one of the things that makes it so fun.
What about, they're voracious, right? I mean, they're in a tough environment. Food doesn't come by easy. They seem to be generalists. Is that true in that they'll eat what's edible, it sounds like?
Absolutely. I mean, the larger brook trout, of course, are piscivores. They will eat small fish too. It's really just gape limited. So patterns, all of the above, but they focus on the benthic, the bottom of the stream, the benthos. So nymph patterns that, makes a lot of sense, droppers, etc. Yep. Anglers know this, of course, but it's that drift line. It's sort of funny how the research world has a complicated way of saying something, and then the angling community has a more straightforward way. You guys get this. But optimal foraging theory predicts the location of an individual trout. It's basically where you expect. It's right behind cover where the velocity is low, but the drift line is high. So they're just hanging out, watching the food come by. It's almost like one of those sushi on a
on the conveyor belt.
On some kind of a conveyor belt. You're just hanging out. And that's what these fish are doing.
Let's talk about the challenges that these fish face. I mean, we know that there's just sort of outright habitat destruction. They're losing forests to fields, to development. We're losing hemlocks, which provide some of the shady cover that keep the waters cool.
That's right.
What are the challenges to brook trout in the Southern Appalachians, other than climate change? What do they really struggle with, Dan?
Well, they are running the gauntlet. There are many different things at work. So brook trout need cold water, they need clean water, and they need complex habitat, woody debris, natural habitat. So what we know for a fact is that when you put in an impervious surface, you end up shooting hot water down through that stream, and a small percentage of the watershed and impervious surface, you see brook trout disappear. But there's something special in spring creeks, in these groundwater-fed streams that come into places like the Shenandoah Valley, where you still see thermal suitability, and the water is cold enough to support brook trout. That's a sign of optimism there. But in terms of the other major threats, a lot of the stuff we look at is the quality of the spawning gravel. You can learn a lot. Just get into a stream, grab the bottom of the rocks, and just see how much dirt shakes off of it. You got a lot of fine sediment and silt. It's bad news for spawning gravels. And that's really what I'm concerned about as far as our ability to restore these fish to their native habitats. They have to have clean spawning gravels for these eggs to survive, because those eggs and larvae, they're undefended. So they need clean oxygenated water during that life history stage for them to produce a successful next generation.
And the dirt and sediment basically starves them of oxygen, right? Smothers them. Is that what happens?
That's right. And there's actually been some recent work showing exactly how little of that fine sediment can choke eggs at that boundary layer. I mean, what really matters for an egg is just that micro boundary layer around the egg itself. And so anytime you have organic material against that egg at that boundary layer, well, microbes are eating that organic material. They're consuming oxygen as they do. And so small amounts of silt and sediment can have a big effect on egg survival. So that's important. However, that's the strategy these fish have used for years. It's not like dirt is a novel thing. They've seen it all, right? So they can deal with a little bit of that. It's fine. It's just that when we convert places from forest into agriculture, or particularly from forest into urbanized landscapes, that's exactly when we see the loss of these fish. There's been some really impressive work on this by Maryland Department of Natural Resources. We're really confident about that effect, but that's not the whole story.
Duck Camp knows that life is not a highway. It's more like a gravel road where the asphalt ends and a chalky white cloud rises up behind to let you know good things lie ahead. Duck Camp's best-in-class fishing and hunting apparel has been tested out there, from Alaska's backcountry to the duck blinds of Louisiana. From buttery soft bamboo sun hoodies to brush pants to iconic Game Series hats, you can gear up for your next gravel road moment at duckcamp.com. There's a litany of threats with the brook trout. I mean, from outright habitat destruction, you've mentioned your issues with runoff. What do you think are the top 2 or 3 things that we can actually do something about in real time?
So we've talked about land use change and conversion from forests to agriculture or to urban. That's a huge one. But listen, I don't think that can be the whole story. In fact, we cannot attribute land use change to the declines that we see in Shenandoah National Park. I mean, this is the Blue Ridge, some of the most intact watersheds that we have left. Protected National Park, the forest there is not changed all that much. And you mentioned loss of hemlock, and there certainly are changes in forest cover that might be important, but what we see is that over 70% of the streams have lost about half of their brook trout numbers over the last several decades, and we just can't chalk that up to land use conversion. That's the atmosphere talking. That's warming of the air and warming of the streams. But there is also some good news I should mention. If you look at the geology of these different watersheds, we see something interesting where watersheds that were historically depressed with their brook trout numbers because of acid deposition from smokestacks, sulfur dioxide, et cetera, coming in, landing in that stream, acidifying that stream, if the geology of the watershed was very sensitive to it. In other words, if it lacked, buffering calcium or magnesium materials inherent to the rock, then those places had depressed populations of brook trout for years, and we see them coming back. Mm-hmm. That's a sign of optimism. And moreover, it's in the presence of warming, they still seem to be rebounding if you've got historically acid-sensitive watersheds. So that's a good sign. It indicates that, the Clean Air Act is probably doing some good for fisheries. But the main thread is that it's the atmosphere talking, both on the warming side, which is troublesome, but also in the improved air quality that we attribute to sort of the rebound of these native fisheries. And that's good news.
So the cynic in me says, all right, we were poisoning them, but we stopped doing that. Now we're boiling them. A little too rough? Jeez.
Well, look.
So, I mean, climate change. I mean, this has come up a lot, Than, as we've done these episodes. I mean, having such an impact on our wildlife.
I'll tell you what, it's true. And I can say it from my direct first-person observation. And I'll have to admit, it's somewhat traumatizing when I'm looking at these data sets that have been compiled by Maryland Department of Natural Resources. They're getting these big fisheries data sets together. It's fascinating. It's great stuff. A lot of work. And I'm looking at them in some ways for the first time to look at trends. And we see trends that I don't want to say it's true, but I have to because that's what I see. I also see warming waters many places. However, there are signs of resiliency out there, and groundwater is a big piece of that. These spring creeks, depending on the aquifer and how water is moving through the earth and the volume of these aquifers, we can have resiliency on the landscape. So that's one thing. And another is that, if we can keep the genetic integrity of these populations intact, then assisted restoration does hold promise. There's really great work here. West Virginia Department of Natural Resources, Brandon Keplinger and crew, they're doing great stuff by taking fish from good populations in the upper Potomac River Basin and breeding them out in a hatchery environment and taking those heritage strain fish and using those to restore populations in spring creeks where temperature is suitable. So kudos to them. And that's another sign for optimism there too.
So, Than, a topic that we haven't spoken a lot about on this podcast, AI. When Eddie and I talk about it personally, we talk about it coming after our jobs, but I know that AI is a powerful tool, and I believe you guys have created something using it that can really be an asset to brook trout.
Well, Dave, I don't want you to worry about your job. You're irreplaceable, so don't sweat that.
Thanks. I'll tell AI that when it comes for me.
Yeah, what we're doing is applying AI in a tool we call Trout Spotter. And this is really exciting to me because it builds community while we build big data to answer questions for conservation of brook trout and all sorts of other trout species too. So here's how it works. So we've talked about the beautiful spot pattern coloration of brook trout, but it turns out that those spots are essentially a fingerprint. They're individually unique patterns. So the arrangement of spots can give you an identity, not just of the species, but of that individual, which is really cool.
Oh, wow.
Now, there are already tools out there for species recognition through images. So you might be familiar with Seek, which is an iNaturalist program. Great. Right. Picture this. A whole bunch of apps are out there already. I love the stuff. It helps you identify species, but we're taking it a step further by identifying individuals using images. So anglers catch a fish, brook trout, snap a photo. They're using the OnWater app, OnWater Fish app, fantastic angler log app, and they hit submit on the Trout Spotter tool there. Boom, that picture goes into a pipeline, and essentially we're using computer vision to identify and remember that individual fish based on the spot patterns. Then you release this fish, good luck, George, and bam, when that fish is observed again, entered through an image submission, you can get a notification saying, hey, we found George. George was here. George survived. Isn't that cool? So you deepen your understanding of the river and the fish, while at the same time, researchers like me get big data to do something special and important. We can estimate abundance. We can estimate trends. We can look at survival rates. These are the things that we really need to know as we move forward, especially right now as things are changing so fast.
So then how does that work on the stream? So an angler must have to register somehow. How do anglers get involved with this?
It starts by downloading OnWater Fish app. And this is a fantastic app. It allows you to log your catch, just to keep notes on your trip. And that's all private information. And I should also say that all of this is private information. No spot burning. We're not going to publish the location.
Hey, that was my next question.
I get you.
I was like, whoa, I'm not sharing. So we're sharing with the scientific community, but not with other anglers who say, oh, somebody caught a brook trout on Tiger Creek,
That is correct. Now, we are going to produce some watershed level state of the science. Here's what we've learned at this watershed or at that watershed. But we're not going to have point locations. That's not something we're interested in. And I think
you don't want to put that pressure on the fish.
Well, that's true. But I think there's so much that we can learn, and that's exciting. And guess what? At the same time, I think we're doing something smart by going to the people that are actually on the water, the angling community, right? I mean, the DNRs of the world, I have such respect for. I'm in the USGS. This is the Department of the Interior institution. We do great work, but they're just not enough biologists out there to do all the work that we need to do. It's the anglers who know these places, love these places, and have a lot to say. So it's about building that community, and it's about engaging the public. And, I have to say, now more than ever, citizen science, participatory science, it's more important than ever because, let's face it, people are asking, who do I trust? Do I trust some scientist somewhere else? No, you have to get involved. And that gets back to the first principle of science, after all. I mean, the first motto of the first scientific society, it was see for yourself. And I just love that.
Yeah.
Nullius in verba, see for yourself. And we're only going to get that if we embrace the community of people that are out there and that can participate with their own work.
All right, Than, I've got a question that tears me up a little. I love fish. But I occasionally love to eat a fish. And I only keep what I'm going to eat fresh. I don't freeze anything. But I've always had the dream of one day being able to catch a brook trout on a tiny mountain stream. And I've have my trusty tiny cast iron with me and to start a little fire and to eat a brook trout. But does that make me the devil?
No, you're speaking my language. I mean, this is the deal. We've got to get there. We've got to get there. Now, you're smart. You'll think about the population where you're fishing, but getting these fisheries back to the place where that can be done everywhere. That's the goal, right? That is the goal. And I tell you what, a little lemon, a little butter, campfire, you name it.
There you go, Than.
Dan, you hadn't seen how much chicken bog that man could put away. You wouldn't be encouraging this. I'm telling you.
I said one trout, Eddie. I said one little guy.
And I'll tell you what, know your population, and this is where you got to pay attention. There's some places where you have 5 fish a day creel limit, and I'd say you put 5 anglers in there for 3 days, and that's game over.
Yeah.
And that's no good. We want to be careful about that.
Yeah.
Another thing we want to be careful about is not overstressing these fish as you take photos for trout spotter. Right? It's common sense, but it's keep them wet, hand net, wet hands, minimal handling. We know that it's not going to kill fish, the amount of stress that's going to be applied, but we have to use common sense.
You said lots of research questions can be answered through this. Dan, what kinds of questions can be answered, and what kinds of questions will Trout Spotter be digging into first?
It starts with how many fish there are. It's just an abundance estimation. And honestly, we have to have individual identities for us to do that because you don't know if you're counting the same fish twice, right?
Mm-hmm.
And this goes back to wildlife biology, I mean, as long as there have been cameras, there have been biologists putting cameras in trees and stuff and look, especially in the terrestrial world. So looking at zebras or other animals with very distinctive markings. And that's been done for years and years, but it's never been automated. And it's also never been done in the freshwater environment. And so that's what we're bringing to the table now.
So other than abundance indices, what can we learn about a stream by knowing that George is a super happy dude right there?
Right. Yeah. So in addition to abundance, we can estimate movement rates. We can estimate survival rates. And this is important. We know from prior work that survival rates aren't the same everywhere. So we want to understand that. And so that can help inform creel limits or other management, elements of management. But it starts with abundance, and then we can look at movement, which is interesting in terms of spawning or other attributes of population dynamics, and then get into survival rates. Survival rates is going to be really interesting. And honestly, that's just something we're not going to be able to estimate unless the angling community gets out there and gets involved with the Trout Spotter and helps us do it.
Yeah, I mean, it's true citizen science without a question.
But I guess ultimately you could get to the point where an angler takes a photograph of a trout, but also could take maybe a water sample or build an even more robust data set.
Yeah, the sky is the limit. With the advent of all sorts of technology in your cell phone, there are a whole bunch of things that we can do now that we could never do before. Another example of that is what we call the Flow Pictures Explorer. It's a USGS tool that allows citizen scientists to essentially use trail cams or cell phone images to estimate the flow rates of streams.
Oh, cool.
And this is another example of how we can use imagery in a new way to measure the things that we care about. And this is particularly important. I mean, if you guys remember, last summer's drought conditions were off the charts. In our neck of the woods here in West Virginia, we had municipal water suppliers going into emergency backup mode, which changes the water treatment requirements, it changes the water chemistry, it changes the costs of treatment, changes the disinfectant byproducts, you name it, and it's because of a drought. So now we have to have eyes on stream flow, and a lot of this, again, goes back to that groundwater story, which is a big part of our research program, trying to understand how water's moving underground that affects the streams above ground, the fisheries, and also ultimately how we use water and our water security.
And just to be clear for listeners, Trout Spotter is a tool within the On Water Fish app, and you can get that from the App Store, right?
That's right. You go to the App Store, find On Water Fish. And also, you can go to tu.org. This is Trout Unlimited.
Yeah,
their homepage,
okay.
They'll have a landing page there for you.
Perfect.
Now, anyone across the country can participate in this, but there are 4 places where we're really digging in with teams of anglers, these TU chapters, Trout Unlimited chapters, and the sport fish community that is going to be participating. The first place is close to home for me. It's the Rapidan River. It's the east side of Shenandoah National Park. Fantastic fishery, huge boulder cascading pool habitats, great water. Then up in Maine, it's the Rapid River and a fantastic large-bodied fluvial brook trout fishery. So we're talking about much bigger fish, migratory fish. Then, of course, in Massachusetts, the Deerfield River, a brown trout, primarily brown trout fishery. There's some brook trout in there too, but and then we look out west, southwest Montana. There are a series of rivers there, not so much their cutthroat water on the streams, but more of their main stem rainbow brown fisheries. So we think this is going to be a great year for this project. But again, anyone anywhere can contribute photos, but when you contribute photos, you're basically helping build the next generation of this AI model. It's the 4 places that I mentioned where we're going to be able to estimate abundance and hopefully survival. At the same time, I got to say, one piece of it makes me a little queasy.
Let's hear it.
Here's the full confession. You know, you're out there on the water. You're finally still. Your mind is finally still, and you're watching that drift. Then, bam, strike. All of a sudden, do we really want to drag out the cell phone for this moment? Do we really want to drag out the tech? That's the one part of it. But I'll tell you the truth is anglers are doing this anyway, and we just have to minimize handling, be smart about it. But let's not let the tech distract us. Right? I mean, it's about the experience, and we hope this will deepen our experience and our appreciation and our connection to the river, to the fisheries, and to other anglers. All of a sudden, you're connected to an angling community. You could learn the history of this fish that you've caught. We've always wondered about that, and now we can actually answer it.
If we can change the visual language of angling from a pier full of dead fish to citizen science, then I'm all for having a bit of technology in the woods.
Well put. And if it means a more productive, healthy fishery, then absolutely. I think it's great. And congrats, Than. I mean, this is really cool stuff.
Well, I appreciate that. We're going to learn a lot this year, so let's stay in touch.
This has been very cool, Than. I'd love to come see your experimental stream lab and then a couple of your honey holes. So if I come knocking on your door, I hope you answer.
I love it. Come on up.
Well, it's a special fish, and it's going to take a special effort to keep it on the landscape. Than, we're so appreciative of the work you do and the other scientists, both the state and the federal men and women who are out there scratching their heads over it. So we got a future for the brook trout.
Amen. Thank you for having me.
Wow. I know what I'm doing as soon as I step away from this mic, Eddie. I'm going to download the On-Water Fish app.
Oh, man. All I could think about is poor little George up there in his little trout pool. His fins are quaking knowing that DiBenedetto's showing up with his 3-weight.
He better be ready for his close-up because I'm coming. But in all honesty, man, what a positive force that fan is.
And it's so cool that this is a way for anglers to get involved. You know, we don't have to sit by the sidelines on science anymore. We can plug in to this project, to this trout spotter, and be a part of the solution.
Yeah, well, you're going to have to catch a fish first, Eddie. Ha! I'm going to leave it at that.
Hurtful.
The Wild South comes to you from Garden and Gun magazine. This is actually the last episode of Season 1, but have no fear, fans. We'll be back with Season 2 and more great conversations this fall. This episode was produced and edited by Christine Fennessy, with music by our longtime friends Woody Platt and Bennett Sullivan. You can find us wherever you get your shows.
And wherever you get your shows, please take a little old half second to leave us a review. These things matter. We care about what you think. We'd love to hear about what you think. So please, leave us a review.
And if we don't have 5 stars, my mom is not going to be impressed. All right, from here in Charleston, I'm Dave DiBenedetto.
And from here in Raleigh, North Carolina, Eddie Nickens. We'll see you next time on The Wild South.